Today I got the new AllPowers S300 300 watt portable power station with 500 watt surge capacity. We're going to run this thing through its paces. I'm going to tear it down, and I'm actually going to try to break it by putting it into an overload condition. Let's check it out. Which one do we get? AllPowers S300. This is the smaller version, so let's take a look at this one. Specifications. It's a lithium-ion battery, 78,000 milliamp hours, 3.7 volts, which is 288 watt hours. It's about 3.4 kilograms. Here's the size, and here's our AC output: 300 watts continuous, 500 watt surge. So this one's not going to run your frying pan, but it will run your electronics, such as your computer and other things. Has 5 amp DC output, 2 times 5 amp, and a 12 volt car port, 10 amps. Has 3 USB, actually 4 USB. So 3 of them are 5 volt 3 amp, 9 volt 2 amp, 12 volt 1.5, and a QC2 or 3 for quick charging. USB 3 is a 3 volt or 5 volt 3 amp, and USB-C, it's a PD 2-way, in 60 watts or out 100, so it can be charged by USB-C at up to 60 watts, and it has an output of 100 watts. Open up the unit. Accessory package, destruction manual, and the unit itself. Has a carrying handle. There it is. Okay, it features wireless charging as well. You've got 2 AC outputs, DC power. I may have to charge it before I can do anything, because it may be shipped dead. DC input on the side and 12 volts output, and of course on the other side it's got your 2 DC outputs and your 4 USB. And see, I probably have to charge the unit before I can do anything, because it looks like it's shipped in a discharged state. Comes with an AC power brick to charge the unit. This has an output of 20 volts at 3 amps. And input 100 to 240 volts AC, maximum 2.5 amps. The charge cord goes on this other side over here, and as soon as I plug it in, it beeped, indicating it's going to do something. The light is on, and it's charging, and it says right here, right on the display here, it says that the battery is at 0%. So we're going to let it charge. I will pick this up once the unit is fully charged. We'll put it through the paces, discharge it at maximum load. So it's a 300 watt unit. I will put a 300 watt load, and we'll run it down, time it, see how long it goes for, and we'll test it with various things on it. According to the display, it's charging at 50 watts. Of course, you can also charge this from solar input. It has an input for solar. Alrighty, now the battery is fully charged. Well, pretty darn close. I've just been trying things out here to see what I can load up on it. And this one can operate while the charger is connected. So you could use this as a UPS, providing that the device is not drawing more power than this adapter can put out. So I think it's what did I say? It was 50 or 60 watts is what it was charging at. So you could draw a light load off of this while it's charging, either from solar or the brick, the power brick. I couldn't test it with my solar panel, because even though I do have a connector for this, it's not the right one that I've got. Mine won't plug in. It looks the same, but it won't connect. It won't lock in. The pin spacing is slightly different. So I was unable to test it. But it does. The manual does say that you can use it while it is being charged. It's just as long as your output doesn't exceed the input, or you'll be discharging the battery. I'm going to turn on the AC on here now, and I was trying to think of what I can connect to this that's going to draw the most amount of watts and to see if it will go into overload or whether it will work. And I was thinking, do I go dig up some old light bulbs, some 100 watt incandescent light bulbs? No. I think I'm going to power my plasma TV, because I have an old plasma TV here that is just a power pig, and it'll draw at least 300 watts. So we'll turn on the power, and we're going to plug in the plasma TV. Okay, I'm going to turn on the plasma TV now, and we'll watch what happens. And I'll kill this light so that you guys can see what it says, and we'll turn on the plasma set. When the set starts up, once the plasma panel actually starts, it should go to full consumption. I'm going to display my security cameras, which is going to be just a static image, 348 watts. We'll start the stopwatch here, and we'll see how long this runs for. According to this, it's going to run for 32 minutes. So let's draw 340 watts from this unit and see if it really does run for 32 minutes. Say this is a lightweight power supply, not a heavy duty one like some of them. While we're doing this, I'll hook up my test cord, and we'll take a look at the waveform on the scope. So there's the waveform. A little bit of distortion here, but nothing really that serious, I don't think. I'll turn off the TV, turn off the load, and we'll take a look at it now with the load gone. We're getting 61.17 hertz. Looks like about 115 volts. I'll turn the TV back on. Okay, the TV's on. Whoa, there's the surge when it kicked in. And the picture's back on. So when it did start up, it drew a little bit of current. We saw the waveform. It did clip a little bit there, but other than that, looking good. I'm going to let the unit run until it shuts off, and we'll time it, see how long it goes for. According to this, it's going to be another 28 minutes. It's been going for about 4 minutes now. So we're going to run it, let it run down to nothing. And while I'm doing that, I'll explore some of the other features on here as well, like the wireless charging and USB while we're testing it. But there's the waveform. Waveform looks pretty clean. You know, a little bit of distortion there, but that's not going to bother anything, really. Nothing to worry about. The unit, of course, features wireless charging as well as your standard USB outputs on the side over here. So let's turn on the DC. You can also turn on lights. It's got 2 camping lights. So obviously something like this is meant for camping. You've got 2 LED lights you can turn on in addition to powering your AC or DC devices. So there's 20 minutes remaining. We're still drawing 345 watts. We'll plug it into USB ports on the side and verify that they are working. So on the side we've got 3 USB ports and a USB-C. Let's just see whether this one works. And that one does indeed work. Charging time 1 hour 16 minutes. We'll see if it does a fast charge. Check one of the other ports out here. Charging time 1 hour 16 minutes. So it looks like these 3 here are just standard charging. Been going now for 16 minutes and 30 seconds. It's telling me there's 18 minutes remaining. I'm going to just let this run the battery down, and then we're going to take this thing apart and take a look at it. Gives you ideas of appliance run times too here. Like a phone, for example, or maybe that's a tablet, I guess it's a phone, 45 to 50 hours drawing 5 watts. A 60 watt device such as a laptop, 3.5 to 4.5 hours. A 40 watt appliance, 6 to 8 hours. A 10 watt, like a battery charger for a camera or something, 20 to 23 hours. 30 watt powered speaker, 8 to 9 hours. A 50 watt fan, 5 to 6 hours. 30 watt light bulbs will run for 8 to 9 hours. And a 120 watt coffee pot, 2 to 2.5 hours is what they're saying that it's going to operate. Now again, I'm giving this thing the acid test. I am running this thing at maximum power. I don't think we can complain about it running my plasma TV. I'll show you the TV. just to show you guys that it is running the TV. If I unplug the power here, the TV goes off and the power will drop down to 0. So I'll plug it back in. We'll turn the TV back on. TV just clicked on. And there it is. Didn't give me the message that the power was interrupted. So we are running 343 watts, another 17 minutes according to the display here. Been going for 18 minutes and 45 seconds. Once the batteries are depleted, we're going to pull this apart and take a look at it. I'm just monitoring the waveform as it's continuing to operate here. Everything's looking good. It's now been going for about 21 minutes. According to this, there's 14 minutes remaining. Still pulling down 342 watts. Waveform still looking good. Our voltage is 112 volts. It's gone down a little bit. 113 volts, 112 volts. So our voltage has dropped a little bit over the time. We're still 61 hertz, so that's still fairly close for a battery powered device. I guess we're okay. With our peak to peak voltage 312 volts, of course, because the 120 volt or 113 volt average is from the 0 point to the maximum, right? So peak to peak, measuring both the positive and the negative, is 312 volts. Battery's at 41%, 13 minutes remaining according to the guessometer. We call these guessometers because, well, you never know, right? They're kind of an estimate as to how long it's going to run. I'm actually quite surprised that it's putting out 355 watts and it hasn't gone into any type of a shutdown mode, because it is rated at 300 continuous. And 500 surge, 300 continuous, and I'm drawing 355 continuous. So we are in an overload condition, yet it has not shut down. Everything is continuing to operate as normal. 24 minutes in, 24 minutes and 28 seconds in. According to this, there's 11 minutes remaining. So we'll see whether we get the full runtime on the battery. Just checking the temperature on it. It's getting a little bit warm on top here, and of course there's warm air coming out of the exhaust. Oh, you know what? It just shut off. That's interesting. Did we overheat it? Like, the voltage went to nothing and it shut off. With 10 minutes remaining, it's been going for 25 minutes. Now, did it shut off because I overloaded it, or did it shut off because I overheated it, or is the battery dead? I guess what we'll do is we'll just let it sit here for a couple minutes, and I'll try to restart it and see whether it comes back on. We may have overheated the unit because, as I said, I was operating it at more than its rated output. 355 watts is what was being drawn. So I'm going to give this thing about a couple minutes just to cool down a bit. We'll try starting it up again and see whether it comes back. Or maybe I burned it out. I guess we'll find out in a minute. I kind of think I probably overheated it because I was overloading it by 55 watts. And as I say, I just commented about the cabinet was starting to get a bit warm, and the air was quite warm coming out here. I've unplugged the TV and I was leaving it turned on so that the fan will continue to run, because if I turn the AC power off, the fan shuts off. So I want to let it cool down. Oh, it's come back on. I just noticed that. It must have just overheated because the power just came back on by itself and I didn't do anything. So we'll plug the TV back in. We'll turn it back on. And you'll see the waveform here. We'll clip a bit as it comes on. There, it's back on. The TV's back on. I'm drawing full power from it again. 345 watts. So obviously that's what happened. Is that I noticed that it was getting quite warm on top, and we'll start the timer up again here. And the air was getting quite hot, and then all of a sudden it just shut off. So we know that the protection circuit works because it shut itself down. I unplugged the TV and just left the unit turned on, and it only took about 2 minutes, and then the power came back on. I didn't have to do anything here with the buttons, and it came back on. So obviously that is what happened. Showing 9 minutes remaining, 28% on the battery, and we'll just let it continue and see if it'll shut down again or whether it'll make it all the way through to the rest of the battery capacity. But that's interesting. We know that the protection circuit works. We'll just look at some of the precautions and so forth. So the Bluetooth app lets you monitor the solar charging. That's what that's for, so you can monitor the solar charging. But you don't need to use it. And it says it's normal for it to become warm, of course. And I'm just looking to see. I'm just looking up for protection and so forth on here. See, the batteries have an 800 charge cycle, so this is something that would normally be used for camping because it's a low capacity, low amperage. And the battery is now run flat. We ran for 28 minutes and 27 seconds, and it says battery capacity is 0 and everything shut off. So we know that drawing 355 watts, it ran for 28.5 minutes. Great. Now I can take this thing apart and we'll take a look inside. I was just looking through the specs to see whether anything about protection on here, and I didn't even get that far, and the battery is now discharged. Okay, here's our protectors. So we've got overcurrent, under voltage, overcurrent, overload, short circuit, overheating, protection. So that's why it would have shut off, because drawing 355 watts, as I mentioned, it was getting warm and it did shut down, and then it did start up again once it cooled. So that's all that happened there. The screws are located under the rubber feet. They look to be hex keys, 4mm hex key. Open the unit up and check out what's inside. Okay, with the screws out, the top should lift off, which it does. We'll unplug the fan and so forth. This is the AC output here. Oh, that's pretty toasty. It's been quite warm. Unplug the fan. And this is the wireless charging. Unplug the fan there, unplug the wireless charging over there, so we can get a look at the electronics. So here's the inverter. It has two fans. It has a fan over here to draw power or draw air in, blow it across the heatsink. Transformers there. We're going to have a series of MOSFETs which take the DC from the battery and turn it into a high frequency AC to go through the transformer, where it's rectified back to DC. That's what that big capacitor there is for. It's a 400 volt. What size is it? 100 microfarad? Yeah, 100 microfarad, 400 volt is all that is. And that's to smooth out the high frequency chopper output from the transformer. And then these transistors over here will generate the AC sine wave signal in conjunction with this big transformer over here. And that gives you your AC output, which is applied right over there. Batteries are going to be below here. I don't know if we can get into that or not. This should come off the top. Oop, this thing's on. Let's make sure it's not turned on power-wise, but it is alive because, of course, the batteries are still connected. Does it lift off? Does the top lift off? We want to see the battery on this thing, what type of battery it's using. I may have to disconnect and lift off the board here to get some more screws. So we'll just try removing a few of these screws. These ones bring power up, it looks like, to the inverter. Wonder if the inverter will lift off. Okay, the inverter lifts off there. Okay, so here is the DC board. As you can see, it's flashing away because it's still got power, and the battery is actually underneath here. So I think to take off this top, I actually have to remove these bolts. And I don't know that I want to go that far. I just don't want to damage the battery. Power is provided through these lugs onto this other board here. This is the AC board. And you can see it's still alive. It's still alive. It's flashing green. Yeah, it looks like this is held in place by these lugs here. I don't know if I can get them out of there. I think this is also the positive terminal, and that is going to be ground. Betcha. Let's just take a look and see here what the voltage is on these terminals. So this one says ground, so if I check across there, it's 13 volts. And there's like 13 volts between that and that. So I'm not going to be getting in there with a pair of pliers to unscrew that, because if I were to short that to that, that's going to give me a dead short on the battery. You see? I guess if I unplug the negative terminal here, I could reduce that risk. But do I really want to take that apart on the unit? I think I'm going to leave well enough alone on this one. And I say that just because it's just not worth the risk with a lithium-ion battery. I mean, even though it's discharged, there is still a charge on the battery itself. And if there was a dead short placed across here, I'm sure there's probably fuses. I guarantee there's fuses on the board itself. If I were to cause a short across here, by just making accidental contact with the negative terminal here, and again, I could remove this and remove that, but I don't want to. If I were to cause a dead short, then obviously the fuses on the battery would hopefully blow. But again, it's a lithium-ion battery, and we don't like to mess around with them. I'm curious as to what type it is, whether they're cylindrical cells or whether it's like a 12-volt pack. So see if I can see it over here, because I can look in the edge here to see what it is made up of. This green light, by the way, that's flashing, that's the Bluetooth board for Bluetooth connectivity. And again, Bluetooth is only needed if you want to monitor and manage your solar charging capability, and it's not needed for anything else. I'm sure there's other things you can do, like check the battery condition and what state of charge they are, but it's mainly for monitoring your solar charging ability over Bluetooth. Anyway, as I say, I'm not going to bother trying to take this out because I don't want to risk damaging the battery or causing a short circuit, which could result in a fire. Lithium-ion batteries are not to be messed with. So I'm going to throw this back together. So here's the critical part. I have to line up these holes here exactly, because this thing's on. So we're going to set it down on top just very carefully like that, on top of the studs, and put the screws back in. I had a friend when I was in high school. He used to get his jollies out of when we were in electronics class, when you're working around something that was, potentially charged, and he had the nasty habit of coming up behind you and yelling, "Bang!" Scare the living crap out of everyone. Looks like silicon wires, silicon insulation wires on the top here. Reconnect the wireless charging. And of course the cooling fan. And the AC output, which I don't think it really matters which one is which, but that's the way it came out. And the top cover goes back on. 4 long bolts go through and secure it from the bottom. Alright, I guess that's probably about all I can show you on this one. I'll put a link in the description. Hope you enjoyed the operation and teardown of this little portable power station. There it is back together. Got it on charge. I just want to show what's going to happen if I run this into an overload condition. So the unit is rated at 500 watts surge, 300 watts continuous. So this unit will draw, I think it's 1300 watts on high power and about 700 watts on low power. 1350 on high, 700 on low. So we'll try running it on low and just see what happens. I guarantee it will go into a shutdown mode for sure, probably immediately. I've recharged the battery, so we'll watch the watt gauge and see how much power it'll put out, or whether it'll even start up at all. So low power. Well, it actually is turning on. Under this resistive load, we're only getting 256 watts out of it, but we know that we had 355 running the TV. But this is a purely resistive load. Now if I turn this to high, what's going to happen? It should shut down immediately. And it does. There's the overload. If I remove the load, it still won't work. It's shut. It actually is shut off, so I have to turn it back on by holding the AC power button. Now I'll turn it back on. I can start it up again, no problem. Go to high power. That's the overload protection operating. So if you do plug something in that draws excessive amounts of current, it will shut right down completely. But as we saw from the test with the plasma TV, I was drawing 355 watts. And I did overheat it, and it did shut down due to overheating after 20 minutes. So at 300 watts or less, it'll run constantly until the battery is depleted. Anyway, that's it for this one. Thanks for watching. We'll catch you in the next one. Bye.